Hi, today we are starting our Essential Math Skills unit. This is mostly going to be pre-algebra skills or maybe even skills you need before that point. But either way, everything you learn here will be something you need to know later, something that builds on itself. First things first, we're going to talk about how to classify numbers. Why talk about classifying numbers? Well, a lot of times on tests, you'll be given questions that might say, given that this is a positive integer, or given this is a whole number, something to that effect, to throw you off. You need to be able to know what our different types of numbers are in order to navigate these types of questions. Now, we have a pretty easy mnemonic device to help us remember our different types of numbers. This doesn't incorporate all of them, but it's a pretty good start to say, never will I rationalize. The N in never standing for natural numbers, the W in will standing for whole numbers, the I for integers, the R in rationalize for rational numbers. So let's start with our most specific category, natural numbers. I've heard them referred to as counting numbers. This is stuff that you can see, feel, and touch in the natural world in front of you. So they are non-zero, they are only positive, and they are only whole, meaning they have no decimals, no fractions. So this is 1, 2, 3, 4, 5, and up from there. Next, we have whole numbers, which are very similar to natural numbers. We've just added 0. So whole numbers are positive or 0, but not negative. And there's no decimals, no fractions, just that whole number, nothing broken into parts. So we can see here in our next slide that everything kind of fits into each other like Russian nesting dolls. We'll continue to come back to these Russian nesting dolls throughout the video, but we see that all natural numbers are whole, but not all whole numbers are natural. Next up on our list are integers. Integers now include negative numbers. So each group that we get to on our list will be slightly more inclusive. We started with the most exclusive, most specific group, and we'll gradually fold more numbers in from there. Examples of integers might be -2, 0, +2, +5, -23, anything like that, so long as it doesn't have a decimal or a fraction. So here we have a new glimpse at our Russian nesting dolls, so to speak. All natural numbers are whole and integers. All whole numbers are also integers, but not all integers are whole, and not all integers are natural either. Our next group is rational numbers. Now, if we're including new groups each time, the next group that we are including are fractions. So this could be any fraction, say 1/2, 2/3, 4/25, anything like that, so long as when it turns into a decimal, it either has a repeating pattern or a definitive end. I like to think of rational numbers as being ones that you can see where it's going. You can predict them. They're more rational than our next group. So they can be negative, positive, 0. They just have to have some kind of pattern or definitive end to them. So now we see again, all natural numbers are whole, integer, and rational, but not necessarily the other way around. Not all rational numbers are integers, whole, or natural. Our next group is real numbers. This pretty much encapsulates everything else but imaginary numbers. So pi might be an irrational number. It's still real, it's just not rational, integer, whole, or natural. Same thing as, say, the square root of 2, or the square root of 3, square root of 11, anything like that. But also other groups we've already included. -5, -25, 73, 23.982, 1/3, anything like that. Those are all real. And again, all natural numbers are whole, integer, rational, and real, but not necessarily the other way around. Our last group, which sort of exists in its own category, so it won't be in our Russian nesting dolls, are complex numbers. We will spend a lot more time on complex numbers later, but what you need to know now is that complex numbers are not real. They are imaginary. Now, you can write any real number as complex. For example, if you just wanted to say 3, 3 would be in that A component. Your A component is whatever is real. And for regular old 3, it would just be written as 3 plus 0i. The bi is your imaginary component. So anything you see written with an I next to it that's implied to be imaginary will be complex, and it should be written in this a plus bi format. Thank you so much for watching this video. I hope you learned something. I hope it helped in some capacity. And don't forget to like, subscribe, comment. It would really help. And have a good one. We'll be back later.